Welcome to today's lecture. We concluded part 2 by saying that we should go and solve the following problems. That means we should attempt to see if we could solve, we should attempt the following problems. Number one, calculate the mass of sodium chloride produced when 5.85 grams of sodium reacts completely with excess chlorine gas while given the equation of reaction and the atomic masses of the elements. Number two, what volume of hydrogen gas at STP is produced when 6.5 grams of zinc reacts completely with excess dilute hydrochloric acid? We're given the equation of reaction, also given atomic masses and the molar gas volume at STP. Number three, calculate the number of moles of carbon 4 oxide produced when 11 grams of calcium carbonate is completely heated. We're given the equation of reaction, we're given the atomic masses of the elements involved. Now, to start with, we're given the equation of reaction, that is sodium reacting with chlorine to produce sodium chloride. What is required from the question? We are required to solve for the mass of sodium chloride produced. In the question, we're told that the chlorine gas is in excess. Let's take the question again. Calculate the mass of sodium chloride produced when 5.85 grams of sodium reacts completely with excess chlorine gas. The examiner already told us that chlorine is in excess. Therefore, sodium becomes the limiting reactant. So you write sodium and what we're told to look for, sodium chloride. The stoichiometric coefficient of sodium is 2. That of sodium chloride is 2. So that's 2 moles. 2 moles. So we need to convert the mole to mass since we're told to look for mass. How do we do that? We multiply the mole here by the atomic mass of sodium, which is 23. That will give us 46. We multiply the 2 moles here by the molar mass of sodium chloride. That will give us 117 grams. Now, how do we get the molar mass of sodium chloride? We do the following calculation. This 1 atom of sodium multiplied by the atomic mass, 1 atom of chlorine multiplied by the atomic mass, that will give us 58.5 grams. Don't forget our formula, mole is mass over molar mass. Since we're looking for mass, it will be mole times the molar mass, and that was exactly what we did. So we have converted this 2 mole to 46 grams and this other 2 mole to 117 grams. Now, I made a mistake here during the calculation. That's why I did this cancellation. So what we're looking at now is that so 5.85 grams of sodium will be required to produce X gram of sodium chloride. So remember, the side facing what we are looking for will be used for division. So what is facing X? That's 46. So 46 will be used for division. Why we say 5.85 grams times 117 divided by 46. That will give us 14.9 grams of sodium chloride. Please always give your answers to 3 significant figures. We go to number 2 now. Number 2 says, what volume of hydrogen gas at STP is produced when 6.5 grams of zinc reacts completely with excess dilute hydrochloric acid? Remember again, the examiner has told us that the dilute hydrochloric acid is in excess. That makes zinc limiting. So zinc is the limiting reactant, why HCl is the excess reactant. The examiner told us that zinc is in excess, so we don't need to go and calculate that. So since zinc is the limiting reactant, we start with zinc, and then what is required is hydrogen, volume of hydrogen gas at STP. So we'll say 1 mole of zinc. Since the stoichiometric coefficient of zinc is 1 mole of hydrogen gas, stoichiometric coefficient of hydrogen is 1, and then we need to convert this 1 mole to mole to volume. How do we do that? We'll multiply the mole here by the molar gas volume, which is 22.4. 22.4 times 1, that will give us 22.4 gm cube. Now, we're not given the mole of zinc that is required to find what we're looking to look for, what we're to get. We're given the mass, so we need to convert the mass to mole. How do we do that? Remember, mole is mass over molar mass, so we divide the 6.5 gram given for zinc by the atomic mass of zinc, which is 65. That will give us 0.1 mole. So we discard this because this is actually what we need. The side facing what you're looking for will be used for division. So x times 1, so x1 will be used for division. That will be 0.1 times 22.4 divided by 1. That will give us 22.24 dm cube of hydrogen. We'll take the last question now. Calculate the number of moles of carbon dioxide produced when 11 gram of calcium carbonate is completely heated. Okay, so we're told to calculate the number of moles of CO2 gas, and don't forget we're given 11 grams of calcium carbonate. And so we take calcium carbonate, and then we take CO2. The stoichiometric coefficient of calcium carbonate is 1, that of CO2 is 1, so 1 mole, 1 mole. And now what we're given is mass, but what we're told to look for is mole, number of moles. So we need to convert the mass given to mole. Remember, we get the molar mass of calcium trisulcarbonate 4, which is calcium carbonate, and then we divide the mass given by the molar mass in order to convert the mass to mole. So 0.11 mole will produce x. The side facing what you're looking for will be used for division. So this is also this step, so we can discard this, x times 1, so x is facing 1, so 1 will be used for division. So we do 0.11 times 1 divided by 1 and equals to x. And then if we do that, we're going to get 0.11 mole of CaCO3. We will conclude by saying that you should attempt this question. Let's see the question. 50 grams of sodium trisulcarbonate 4 reacts with 50 grams of dilute HCl. Calculate the mass of the excess reactant left. Number 2, the percentage of the excess reactant used. Number 3, the volume of CO2 gas produced at STP. You're given the equation of reaction, and then you are given the atomic masses. For this very question, you will need to determine the excess and the limiting reactant. If you do not know how to determine the excess and the limiting reactant, you would need to visit the part 2 of this series, where I dealt with how to resolve problems concerning limiting and excess reactant. I'll see you in the next lecture.